Good evening, everyone. Welcome to our webinar, Reach for the Stars, What It Takes to Work at NASA. Please remember to keep your cameras turned off and your microphones muted. You can ask any questions in the chat and we'll get to as many as we can. This video is being recorded for future viewing, so let's get started. My name is Dylan Johnson, and I am the president of the engineering fraternity on campus, Sigma Phi Delta. The idea for this event was initially going to be for recruitment, but with the help of the engineering department and my fellow fraternity members, it evolved into a wonderful educational opportunity for all of the attendees here. Now, without further ado, I would like you to meet our first speaker, Mr. C.L. Ross. He's the NASA Safety and Mission Assurance Directorate and Safety Manager.
I guess good evening, everyone. I hope everybody's doing fine today. Thanks for the opportunity to come and talk with you guys. As Dylan mentioned, my name is C.L. Ross. Sorry about that. I currently work at NASA. I've been working at NASA since I graduated from Lamar in 1984 and worked on various programs there. And some of the things that we do, you've probably seen a lot in the news about NASA and our SpaceX contingency and our international partners that we work with. So we have a launch coming up in a few weeks for SpaceX that would be very monumental for us, going back to dock with the International Space Station. We also are working on an Orion vehicle that we currently have, which will be our our impetus to get back in space on the U.S. soil. So we're working on that. That should be coming up very soon within the next 12 months or so. A little bit about me. I started working at NASA in 1984, January of 1984, as a quality engineer. I graduated with a mechanical engineering degree from Lamar University. As I started to work at NASA, I worked on multiple programs, from the Space Shuttle program, the thermal protective systems, the life support systems. Did a lot of traveling between Florida, Houston, California, Huntsville, Alabama, and came back and got into several management positions out there at the Space Center. As a result of that, I was able to work on all the new programs that we currently have going on, which was the spacesuits, EVA spacesuits, which I worked with quite a few astronauts on the training and development of the spacesuits, so that when we have to go do a spacewalk, which we call an EVA walk, that they're safe. And the spacesuits are similar to a small spacecraft with its own life support system in it. And so we use that to keep the space station maintained, as well as to do spacewalks when we were flying the shuttle program. And we're currently working on a brand new suit that will take us back to the moon and to Mars, which is called our XEMU suit, which is a little bit more robust than the current suit that you guys see on the CNN and on the news reports. So if you watch NASA Select TV. But I've been fortunate to work with quite a few engineers from multiple areas, multiple schools everywhere from Texas to Texas A&M to Purdue to Harvard to MIT. And I think the ability and the skills that I learned while being a student at Lamar has prepared me to compete at those levels, multiple levels, with those individuals from those types of what you call quote unquote Ivy League schools. What does it take to work at NASA? Definitely have to have the skill to do that. You have to be able to think innovatively, think out of the box. You have to be able to think from an engineering perspective, even though NASA runs like a business. So we have engineering departments. We also have testing departments. We also have vibration testing. We also have a procurement department, which is a business department. We have a legal department, like a law department. So it's kind of like a little business within itself. So there are multiple areas, and we don't just hire engineers. We hire business people, we hire procurement people, we hire attorneys as well, to make sure that we stay within the realms of what we need to do at NASA. I guess a little bit about me. I've just recently moved to a different position. I was a division chief at NASA, where I ran quality and flight equipment division for several years. And that division was responsible for providing safety, reliability, and quality engineering to SpaceX programs, advanced exploration system programs, EVA programs, our training programs, our current testing programs that we have on site at Johnson Space Center, as well as working in conjunction with the astronauts to assume that they are safe, and when they get on the vehicle, that the vehicle works properly. And if we have any failures while we're in orbit, while we're flying the vehicle, that it fails in a fail-safe posture, and we get those individuals back home safely. So one thing you got to understand by working at NASA and working in safety and mission assurance is that space flight is not safe. It's not 100% safe. So if anybody tells you 100% safe, then they're really not being as open with you as they can. But what we do in my expertise that we work in is that we identify the risk of flying to space, which will be going to the moon shortly, and we're currently orbiting Earth, going to space station and coming back. And we mitigate that risk by building a factor of safety into our program, as well as into the hardware that we design. And the impetus is that we make sure our crews are safe, we make sure that we get them there and back safely, and we complete our mission. As our vision is for NASA for the upcoming years, our vision is dare, unite, and explore, which means we dare to do things differently, which we are privatizing some of our activities. We're exploring, continue to explore the universe, and we're uniting with international partners as well as private sectors like Elon Musk at SpaceX, Intuitive Machines, Axiom, Blue Origin, Blue Horizon out of Florida. So we have quite a few things going on within the NASA community. And we're focusing, NASA itself is focusing more on research and development. So we are kind of pushing some of the other space flight development activities in terms of rocket development out to some of the private sector organizations, which creates a way for us to do something differently. And we kind of like we reinvent ourselves as we go forward into the new century, as we move toward our Gateway program. And Gateway is kind of exactly what it means. It's going to be a depot between the Earth and the moon, which is a gateway where we can stop before we go to build our depot on the moon. And that will give us our confidence to build up as we go forward and proceed to Mars, which is our final goal. One of the other things that's amazing about NASA is that it's diversity. We kind of build our teams around diverse individuals with different backgrounds, which from that perspective gives us the best of the best in terms of the minds, in terms of the exploration, in terms of design, in the terms of meeting our goals as an agency, as well as a center for Johnson Space Center in Houston. So by promoting diversity and inclusion, we were able to make sure that we are meeting all the needs that we have from a institutional perspective, from a safety perspective, as well as from an engineering perspective. And it helps us to get a well-rounded design when we want to move forward to try to achieve our new goals. And we're mostly from a design factor, we like to have individuals that can push the envelope, but still understand how we need to get there. So we need to know if there's something wrong, we want to know early so we can go and fix it, and we can mitigate it. And we don't want to find out at the last minute. So that's how we kind of design our teams to be efficient and productive. Several of the things that I kind of live by, a few tenets I live by is probably, the main one is to be true to yourself. And one of the most important ones is to be smart enough to know what you don't know. And when you don't know it, you need to ask someone so you can find out how to do that. You don't need to be the smartest person in the room, but you should need to know where to go to find the answers, right, to become intelligent enough to make the right decisions. And also you have to have enough confidence in yourself to tell truth to power. Because sometimes you might be the only person in the room that sees something that's not quite right. And it might be your question that can save a person's life in the business that we're in at NASA. So I've enjoyed my 37 years and several months there. I didn't think I was going to be there that long. I gave myself about 3 to 5 years to be there, but I've worked on multiple programs there. I've had incredible opportunities. I've met astronauts, I've met senators, I've met directors, and I've worked in DC, I've worked in Florida, I've worked in Amsterdam with the European Space Agency, I worked in Japan with the Japanese Space Agency. So it's been a very, very enlightening experience for me, and I've been blessed to be able to take advantage of it. Any questions? Oh, what I didn't say is, I should have started off with that, is that I am from the Golden Triangle. I'm from Port Arthur, Texas. I graduated from Port Arthur Lincoln High School. I won't tell you what year because that's going to date me really bad. But I am a product of the Golden Triangle.
We are actually going to save questions till the end and
Okay.
move on to our next speaker. Our next speaker is Mr. Garrett Turner. He is a civil and environmental engineer with more than 35 years of experience. He has a bachelor's degree in civil engineering from the University of California, Berkeley, and a master's in systems engineering from George Washington University. And he currently works for NASA's Ames Research Center as an environmental engineer.
Got to hit the unmute as well. Good afternoon. It's a little earlier in the day for me than it is you. I had a slightly different experience getting to working for NASA. I started a bit later, so what happened to me? Well, prior to college, I was not an engineer. I didn't even know what an engineer was. I knew I was good at math and science, and that seemed to be the ticket to define an engineer. So I applied to UC Berkeley and the College of Engineering and ended up choosing civil engineering. Had an ROTC scholarship with the Army and graduated 5 years later. So what is civil engineering at Cal? Engineering and project management, something that's very useful for NASA, but also, throughout the world. Environmental engineering, protection of the environment. Geoengineering, improving the human condition or sustainability. Structural engineering, mechanics, materials. In civil engineering, it's more buildings, bridges, and dams. Transportation engineering, road design, public transportation planning. We don't really talk much about spacecraft in civil engineering. And then civil designs, interdependent elements, how different civil systems work together. Some pictures, we'll kind of skip through those. So I became an Army officer in the Corps of Engineers, was stationed in the Republic of Panama, built and designed roads, bridges, and airfields. Had a great opportunity to practice all the engineering skills that were part of my degree. Had a surveying section, learned a lot about that, learned demolition and defensive systems. It was validating what I'd learned in school, which turned out to be pretty important. When I finished with that, I returned stateside and I was a construction manager. So I was looking for a job and ended up with an environmental company and started designing hazardous waste landfills, using all of the same civil engineering requirements, landfill caps, earthquake stability, understanding materials, channel designs and flow paths. Started designing groundwater treatment systems, soil excavations, and then the other part that didn't get mentioned by Mr. Ross is there are a lot of regulations and permits required with everything NASA does, and I did as a civil engineer. So worked with RCRA permits, CERCLA permits and Superfund, and after a series of 4 different exams, became a professional engineer in California as a civil engineer. I moved to another company, Science Applications International Corporation. My previous supervisor had worked there, and I started working for the EPA, doing documents for, document reviews for them, and worked on site at LBL, and got an opportunity to work at NASA Ames for the first time. Was there for 4.5 years, working on environmental compliance, remediation, emergency response, planning under the National Environmental Policy Act, all of it building together different pieces. I was with a large business. NASA likes small business contracts, the federal government does. So when the next contract came around, we lost and went back to the home office for SAIC, started doing more work with litigation support. Started doing systems engineering. SAIC paid for me to get a master's degree in systems engineering so that I could lead a systems engineering group. But I kept working in remediation as well, and then joined the Project Management Institute, PMI, took an exam to become a project management professional, tying back in the need to not only do engineering directly, but also to manage engineers, manage programs, manage processes. After a few years, I returned back to NASA as a deputy program manager and took over the program management position. Had about 45 staff that were supporting the environmental division, as well as the industrial safety and occupational health. This was where I got to do a lot of management, a lot of project management, and very little actual engineering, and learned more about protecting the workers, protecting the workspace and the work environment, as well as the natural environment. Just over 5 years ago, I finally became a civil servant and took over the water programs, managing the water programs in the environmental division, drinking water, stormwater, industrial wastewater, and spill prevention, control, and countermeasures. Once again, I was an engineer, had to use my civil engineering skills, and no supervision of personnel. After a while, after many years, that was really a relief to be able to be an engineer again, get back into all of that. Of course, that didn't last nearly long enough, so I ended up becoming the contracting officer's representative and managing the contract. A couple of years later, the remediation program manager, who was there before me for the cleanups, left to take a position at Goddard Space Flight Center back in DC. And so I took over her job, and now I was responsible for cleanup again of landfills and contaminated groundwater plumes and large structures. Kind of circling back around, a lot of things tie back together. Additionally, I got an opportunity to assist NASA headquarters Office of Strategic Infrastructure with reconfiguring and optimizing the organization. They're in the middle of a 2-year process, which they're hoping to get permission to reorganize towards the end of June and actually be in a more efficient way of working. So once again, it's project management skills, it's how to develop organizations. So what's civil engineering career been for me? Well, these are all the same things I showed you before. It's just, now it's leadership in construction and project management. There's my PMP work, protection of the environment, remediation, and my professional engineering. Geoengineering, improving the human condition, sustainability, and industrial hygiene. Structural engineering, mechanics and materials is the landfill, bridge, and airfield design. Transportation engineering, road design, and civil systems, so my entire master's degree was in. So what am I doing now? I'm the restoration program manager, the sustainability lead, and the contracting officer's representative. I'm on the medical emergency response team, which gave me an opportunity 2.5 years ago to come back to Texas for 2 months to support FEMA for Hurricane Harvey support assistance. I still have no direct personnel supervision, as those are at the chief level, but I'm a formal mentor for staff in the water programs that I no longer have in the Corps on managing the contract and sustainability. What's an average day? Not that any of them really are. Zoom meetings or Teams meetings with co-workers located throughout the US. Discussions and negotiating with regulatory agencies, the EPA, California Regional Water Quality Control Board. Management meetings with my boss. Discussions with support contractors. Managing the work product of support contractors. And a lot of writing. Emails, reports, presentations, performance work statements. You know, the one piece that I would offer up as advice is take another writing course. Whatever you're doing in your career, take another writing course. If you can write better than the other engineers, they're going to want you. Everybody in engineering can do a lot of the engineering, but they need people who can write about it and talk about it. What do I enjoy? I like helping people find solutions, helping to find answers to our problems at Ames on how we can clean things up, how we can lease out new part of our property. Johnson may be facing a little of this with some of your ancillary facilities. We took over a naval air station, which was co-located with us, and now we are leasing that contaminated property and having to figure out how to identify what the risks are associated with that. I like the wide variety of work from remediation to sustainability to contract management. I mostly work with smart people who care about what they're doing. NASA is full of people who really like being there and they enjoy it. And I know my job can make a difference with the environment and people's lives. So what's my actual space part? Well, I was actually, I competed and was selected to attend the International Space University Southern Hemisphere Space Studies program in January and February of 2020, right before the pandemic hit most of the world. It was a 5-week intensive program. There were 53 students from 14 different countries. We had 3 weeks of lectures and workshops, and we culminated with the team project, Lunar Agriculture, Farming for the Future, which was a 40-page technical paper and a 60-minute presentation. We had to figure out how to take 10 people living on the moon and feed them for a year, address all of their physiological, psychological requirements, all of their nutrient requirements, develop the structure to keep the farm from being destroyed by the cold. It was great. It was outstanding. And we had the extra bonus that afterwards, we submitted abstracts to 2 separate conferences, International Astronautical Federation and American Society of Civil Engineers, and they were both accepted. And neither conference ended up being an in-person one, so no travel to Dubai or Seattle, Washington, but we've presented the material virtually and papers are published for each of those, all from International Space University. They are looking for recent graduates. They have many scholarships for people to attend their different programs, and it's a good way to get into the space business. There are about 6,000 alumni of International Space University's programs, and they help each other find jobs in the space business. It's been amazing kind of watching that. I was one of 2 NASA people at this program. I get a number of people who reach out and ask me questions about who do I talk to at NASA about this, or how can I do that? And I can do the same with the Australian Space Agency, the ESA, European Space Agency, all over the place. So that was my space assignment. The rest of it was taking all of my civil engineering and career to build up to being able to do this. And questions and answers will come at the end, but it has been fantastic working for NASA. They gave me opportunities that I didn't have other places, and I really appreciated the chance to come and talk to you today, and look forward to any questions you might have.
All right, thank you, Garrett and Mr. C.L. Ross. Our next speaker is Dr. Jordan. He is a Lamar alumni and a professor at Lamar, and he is a professor of Earth and Space Sciences.
I think I'm the oldest guy in the room. I'm pretty sure I am now, having heard everyone else's. I started with the space program. I grew up here. I lived in north end of Beaumont on a lonely blacktop road, and we had no street lights. And the significance of that is that we had a very clear, when the cloudless night, I could see the Milky Way. You cannot easily see the Milky Way anymore in America because of light pollution. So I had the advantage back then of no light pollution. The space program was just starting. And in fact, I was looking to the sky for one satellite. Actually, it was a high altitude balloon called Echo. And I could see it dancing in the sky. It was a fascinating sight. I started looking at the moon when I was in junior high, and took pictures and shared them with everyone in junior high. And Kennedy had announced to space that we were going to the moon, and that set me on my path. So there was one other reason. There was another thing going on at the time. And I also looked west from that night sky that I used to see out there, and would feel the fear that I might see a bright flash, and that would have been nuclear war. So we were in a period of threat of nuclear war and a period of a space program. And it was, by the way, not bad for science, but in any case, those were the drivers. I went to Lamar. I knew already that I wanted to work in the space program. I studied geology, and I applied. Once I graduated, I applied to various schools. I got accepted to Harvard, Columbia, and Rice. And I found out that Rice had lunar samples, and that was all it took. I was invited to come over to Rice the summer after I graduated from Lamar, and began working on lunar samples, which I knew very little about. But in any case, I got to weigh the first samples in the summer of 1971. And I just stared at the weighing tray, looking at pieces from the moon. And I still had that fascination. There was a huge number of science and engineering going on worldwide. Apollo had funded the world's labs to improve themselves with a considerable amount of money. So the lunar science conferences held at Johnson Space Center would have international presence, basically. And I got to know a German group that was from Max Planck Institute for Nuclear Physics. And after I finished my doctorate at Rice, I got invited to Max Planck in Germany, in Heidelberg, Germany, to work on lunar samples and other things extraterrestrial. So, the European Space Agency had formed, and there was, in any case, when I got to Max Planck, I was assigned to work with some graduate students, and one of those graduate students eventually graduated, went to work for ESA, and then became mission director of their missions. And they had one mission where he intercepted a comet and landed on it, comet 67P. We had planned the Halley interception, the Halley Comet interception from Max Planck when I was there. Basically, it was, even though it was Max Planck Institute for Nuclear Physics, it was a space physics group that I was a part of. And I had, it was an international thing. We were going all over the world telling stories about what we were learning. And I was invited to go to Caltech, but I actually turned them down. So I came back to Beaumont, and I knew a lot of folks over at Johnson Space Center. There's a Building 37 was the Lunar Receiving Lab, and Building 31 was the Space Exploration Division. And there I contacted my friends, I guess you'd call them, and said, is there something I can do over here? And I did the American Association of Engineering Education, and then I did a National Science Foundation, a National Science Academy thing of 1 year at Johnson Space Center. But moreover, I have done a lot of things with Johnson Space Center, and that includes students. So this is one thing I think I can say to students. There are a number of student programs that are, I know there's a number of programs you may be aware of that are, at your university that you can do to help NASA do something. But there's programs as well that go on at the location at Johnson Space Center and other centers. I would definitely recommend trying for those. Why? Because your presence is everything. We participated for almost 20 years. I sent students on board the weightless aircraft from the Reduced Gravity Office over in Hangar 990. And we had 14 wins of projects that we wanted to fly. With each project, you get 2 flights. So we had 28 flights, and usually somebody got sick on one of those flights, and they would ask if anybody else would want to get on it. So we had more than 28 flights. Our presence at Hangar 990 was pretty well known. And one of the things that I knew from talking to them there, and they had an education division there to talk to. They said it was a recruitment program. They looked at it as a recruitment program. And so we had one electrical engineer. He got sick on both flights. However, and he took a course from me called Rocketry and Payloads. I invented that course. And he took his experience and he went to NASA, and they said, "Oh, this course here, what is that about?" And he said they were more interested in that than some of his other courses. But in any case, he started a 16-year career at Johnson Space Center as a double E. He was being groomed, I think, to be an AA, but he decided he wanted to go back to his roots in Louisiana. So that's where he is. But we have, when I was working over there for the year or a year and a half, so I've looked for all the Lamar graduates that worked at Johnson Space Center. And that was, I think, 1990 or something like that. And it was 137. We took pictures of the group. In any case, we have the personality profile, I think, to work at Johnson Space Center. I mean, our students do. I often describe the the students from Lamar is having a wrench in one hand and a calculus book in the other, because we are nuts and bolts people. And so it has been something I've clearly recognized in our group. I would say, Caltech is one place, but JPL is yet another. And so the Jet Propulsion Laboratory, although it's located at Caltech, has got its own breed of people. And I think our engineers, our people are qualified to work there. So I think that's a place to look at. So I have basically been around quite a while with the space program, and I have used that opportunity. By the way, the department I'm in is called Department of Earth and Space Sciences. I'm chair of the department. When I became chair, I decided to change its name from geology to the Earth and Space Sciences Department. And I created 7 courses that were called space science courses: Introduction to Space Science, but also had space transportation systems and other celestial and orbital mechanics. And I did that at the recommendation of the director of Johnson Space Center. I used to visit with one of the directors a while back, and I visited about twice a month. And I worked with, in any case, he said, these are the courses we think a university ought to try. And so we did that. And basically, we have, quite frankly, I think we have the profile of the students. We just need, I think the students need to go take advantage of programs that the Space Center has, and that not only includes Johnson Space Center, but other centers. And if you can go there, that's the best, because once your presence is there, it's almost like recruitment. So that's where I'm about, and I open it up to questions.
We're saving questions for the end, Dr. Jordan.
Yeah. That's right. We've got one more.
Our next speaker is Mr. Marcus Rogers. He's an aerospace engineer and Lamar alumni.
Hello. My name is Marcus Rogers. I just graduated last May, so I haven't even been working a full year yet. So I don't have nearly as much experience as other speakers. So you can take what I say with a grain of salt. But I'll just give a little bit of background about me, what I've done to kind of start working at NASA, and then kind of what I think is best, what my experience has been. I came to Lamar in 2014. I graduated with a mechanical engineering degree. I did multiple internships, once with the paper mill in Evadale, another with a chemical company in Baytown. Nothing at all having to do with space or aerospace, anything like that. I got involved with a lot of stuff on campus. That's the big thing I recommend, is just getting involved, doing what you like. I worked for the Rockwall. I was a Lamar ambassador, engineering ambassador, did all sorts of stuff I could, just for the fun of it, really. So I did those internships, got my foot in the door, met C.L. Ross, great guy. And finally, after applying, I don't know how many times to NASA, I was finally able to get an internship. And once you get your foot in the door, it's like they're trying to recruit you. So I started working out at CC3, which is our division codes, aircraft operations, out at Ellington Airfield. It's where actually 990 is. Unfortunately, we don't have the vomit comment anymore. We got rid of that just before I arrived. but we still have a lot of other aircraft, which I'll talk about later. But started working out there, did a tour out there, did a tour in the robotics division in engineering, which is completely different, other side of the scope. And then, but I loved aircraft operations so much, I went back, and that's where I'm working now full time. So some of my internship projects that I did, my very first project, I actually did a tire wear study for the T-38s, which are the jets that we fly. They're trainer jets that the astronauts train in for different missions and things. They also take them across country if they have a speaking engagement or something. But it sounds really boring, but I literally went out every day and took photographs of the tires to see how they were wearing. And did this for the entire duration of my internship. What was really cool about that was I got to get hands-on with the jets. I got to know all the maintenance people. I got to know some of the astronauts really well. I actually even got to go give a speech to all of the current astronauts that were there, and just teach them how to read the tires, what to look for in the tire wear. So whenever they're doing their walk around before they fly, that everything's good to go. So that was one of my favorite experiences. In the robotics division, I was able to work, we had this, oh, now I'm gonna forget the acronym, but it's a replica of one of the arms on the ISS. We were updating it. It was pneumatically controlled, and now it's all electric. So we had to update a whole lot of stuff with it. And my job was pretty much making a huge enclosure box that could fit a lot of the electronics and stuff we needed. So I was able to sit down and design, hey, this is all this box, we got to put all this stuff in there. I 3D printed a lot of stuff, CNC'd some stuff, had some stuff water jet, tapped over 150 holes by hand. And then I found out that they had machines that can tap it for you. So that was a whole day wasted, but it's just different stuff like that. You get hands-on, and that project is still being used to this day. It's attached to the robot, ready to go. I just saw it a couple months ago. But the main thing I say that is because when you're doing an internship, you don't get just busy work. I mean, you don't just sit on your hands and be like, oh, look, I'm at NASA. You actually get to do stuff that's productive, that helps a lot. A lot of the projects that I've done are either still being used or they accomplish their function. There's one intern right now is working on an environmental testing rig for one of our windows, and that's going to be used for as long as we have those windows. So for the next several years, at least. It's just things like that that you really get hands-on. You get to build stuff up. I went through several classes learning how to solder properly, drilling, machining, all sorts of stuff that I was able to learn. So you can really learn and work with engineers, work with maintenance, like I said, astronauts, anything, and just have fun doing it. Some of the stuff I do now. So like I said, now that I'm working in aircraft operations, we have T-38s, like I said, our jets. We have two different Gulfstreams. We have a G3 and a G5. Our G5 is our most recent acquisition. It was actually Nike's old corporate jet. It still has the Nike swooshes on the steps whenever you walk up. But that was, we have both of those, and those are for returning astronauts whenever they come down from the ISS, or if we're taking them to fly up to the ISS. They go and get them and bring them back home. We have both in their spare time. If they're not doing that, we also use them for science missions. The G5 has two huge 18-inch windows in the bottom of the aircraft that we have cameras, different things to look out of, that take scans of the landscape and stuff. JPL does a lot of their imagery with that as well. In fact, one of my projects whenever I first got on full time was installing some optical windows on the side of our G3 for different analysis and things. So we have our Gulfstreams, the WB-57, which is old spy planes that we have 3 of them that have been kind of converted to high altitude research. So we send up different payloads, and we have several different pods and a bay that it sends it up, and they collect different data, whatever research is doing on those. And we also have the Super Guppy, which is just a giant plane that can actually haul other planes or other spacecraft parts inside of it. Things like that. Like Orion Heat Shield, it's one of the big missions we did recently, hauling that back and forth across the country. So what I do full time really, when I first got on, I created a CAD model of the G3 and an AutoCAD model. So I used Creo and AutoCAD to make a 3D model and a 2D model. So we can use those for laying out our science experiments, how they need to sit in the cabin. First off, to make sure everything fits, and then safety and things like that. So you do a lot of drawings, you get a lot, you're able to work a lot hands-on with the plane, figure out stuff like that. I've also been working on installing some cameras for a mission that actually is currently going on. So they're taking scans with some radar. Then they're also using the cameras, and they're taking, so the radar's at a 45 degree and the cameras are also at a 45 degree, and they're overlaying those images so they can kind of see better what they're looking at for those missions. Again, JPL is collecting all that data. We're just facilitating it with our aircraft. Let's see some other stuff I've been working on. So like I said, get a lot of hands-on. I'm able to actually build a lot of the stuff that I designed, or I help people build it, like build up the windows, optical windows, things like that. With the T-38s, they're pretty old planes. They were only meant to last 20 or 40 years, and now we're up to 60, I believe. So they've been past their lifespan. So the main thing we do with the T-38s is make sure they're still functioning, upgrade them, fatigue analysis, things like that. So it's really, really good to learn MOS, to learn statics, a little bit of dynamics, things like that. You really use those. Other than that, so the big things that I learned that I think are great takeaways that that you should know if you're trying to get a job at NASA, what you're just even any career really. It's kind of diversify. Don't just do your courses. I mean, courses are fine and all, but some of my favorite things I did at Lamar had nothing to do with my engineering classes. I took an art class just for the heck of it. I mean, you do different organizations and you learn so much more because you get different perspectives. You get hands-on with so many other things, and really do co-ops and internships if possible. That was what made me choose Lamar versus other places. And what I've been told by countless people is internships and co-ops are how you actually is how you get experience and how you can get the best jobs. If anybody has any questions, please post in the chat. I think that about wraps it up for me. So yeah, take it away, Dylan.
All righty. I have some questions that we came up with, and we will be taking some of the questions from the audience. One of the questions was, what traits and experiences do you believe made you competitive when applying to NASA? And that's open to any of the speakers.
I would say what made me competitive was understanding since my job was a civil engineering job, it was understanding the actual engineering behind it and the willingness to try different things. So, my combination of engineering and management was something that attracted my boss to being able to let me in. And the other thing that helped, I had a veteran's preference. So actually working in the military gave me a preference in my hiring. So, for those of you who aren't sure exactly what you want to do, the military turned out to be a very useful thing for me there, because I got to practice my engineering and it gave me some preference points when I was applying to NASA.
Alrighty, a question for CL Ross. Please summarize the role and importance of human factors engineering in the design of the vehicles and spacesuits.
A very good question, because we spend an enormous amount of time working with human factors, primarily because when you have the astronauts in confined spaces, they need to have the most ergonomic designs as possible so that they can be as efficient as possible to complete their mission and complete their goal while they're flying. So we spend an enormous amount of time designing spacecrafts, designing robotic workstations. For instance, space station that we currently have flying now, which is flying 24/7, 365, with 7 to 8 crew people on there from all international partners, from France to Japan to Italy, of course, the US, Germany, and I mentioned France already. So from human factors perspective, we try to make it as ergonomic as possible. Try to make the equipment as user-friendly as possible from a IT perspective as well as from a physical perspective. We go over multiple design reviews, from preliminary design reviews to critical design reviews to actual implementation and manufacturing. And then from there, you get into the testing phase of it, where you have to test it to make sure it works properly. And that from the testing phase, you can go and do multiple redesigns from that perspective.
Alrighty, a question for Marcus. One of the members in the audience said, I have applied twice to NASA with experience from the semiconductor industry and an associate's degree in nanotechnology, and am currently a junior as a chemical engineer. What else can one do to stand out in an internship application or a co-op?
I will try to answer that to the best of my abilities. So there's a few things that I was told. My father-in-law, he hires people at Exxon, and then I know several other people in various companies that are on hiring boards. The main thing they look at a resume for 30 seconds. And if you don't impress them in that 30 seconds, they'll move your resume to the bottom of the stack and keep going. So it's really, big thing is just make it different, stand out. Like I said, you want to do things outside of your curriculum, because everybody does those same things. It's the things that you put on there that other people don't normally do, or the things that make you stand out. So like I had the Rockwall on there. I was the Rockwall manager. That always got a question. Let's see. As a mechanical engineer, I put stuff about electrical on there because I was interested. And I taught myself some stuff. And so that people ask questions about that. So really just things outside of your field that they don't normally see, they're not expecting, is really how I got, was what I've been told, really. And if anybody else has any better inputs, feel free.
Okay.
Yeah, I'll take a shot at it real quick, Marcus. I know I do a lot of interviewing for interns. I'm on multiple interview panels being a directorate manager. And one of the things that kind of get you there from the human resource perspective is first you have to have at least a 3.0 GPA minimum to get even considered. And then they look at your extracurricular activities as well as being a, technically competent. Unfortunately, when I was hired in, I was involved in multiple other programs. Other things at Lamar. I'm continuing to be a member of Omega Psi Phi fraternity, which taught me a lot of management skills and how to deal with people in multiple levels. So they look for that area. And as Marcus said earlier, you have to figure out what sets you apart from the other applicants, because you're going to be competing with folks who have degrees, who have experience, some co-op experience, as well as in terms of if you're coming fresh out of school, it'll be individuals who might have higher level of educational experience than you. So what sets you apart? What other extracurricular activities you're involved in? Because what we look at is, you're going to have to be able to do the work that we assign you, as well as take care of personal things as well. So soft skills are good. I think Garrett mentioned being able to write is outstanding, and being able to present and communicate is also as well as outstanding. That's it.
All righty. Next question. Collectively, you mentioned hires from majors besides engineering. Where would, say, a computer science and mathematics major potentially be hired? Would it be more appropriate to get a master's degree in an engineering field?
Computer science majors are probably in our IT department. I'm not sure about the other centers that some of the other gentlemen might be familiar with. Actually, if you have a mathematics major, you're actually considered a scientist, according to the HR policy at the space centers. So you can be hired in as an engineer and be taught how to work as an engineer. You won't have the engineering class training to do that, but we have hired mathematics majors as well as engineering majors. And I have just a couple of gentlemen who are mathematics majors that work for me, actually, in different capacities.
So I can also add just a little bit. For computer science, there's a lot of opportunities all over. I know in AOD, they're always willing to get computer science interns because there is a lot of program stuff that goes on as far as like some of the autopilot, things like that. In my internship in the robotics side, I worked with a computer science major, and he did a lot of the graphical interfaces for the robotic arm, so we could actually use it and not have to type in a command string the whole time. And he worked a lot with the cameras, trying to get things functional, operational, actually looking good too. In the flight side, there's a lot of different computer programs that you could be hired at. In the engineering side, there's also a lot of programming and things like that you could get. So.
There are a lot of non-engineering positions in NASA. Working in the environmental management division, I'm one of 2 engineers. Everybody else are environmental specialists. So we have planning specialists who help with long-term planning of environmental impacts. We have chemists. We have geologists. NASA's going to get a lot of samples. They're going to bring them back. They don't necessarily need an engineer to look at it. They may actually need a geologist or somebody who understands what the materials are. Additionally, there are a lot of toxic atmospheres that NASA has to address. So we're looking for research chemists who are willing to look into those atmospheres and do a lot. We've got a lot of bio engineering that goes on, where we're looking at different samples that come back, because we don't want something brought back to the Earth that turns out to be a virus that causes problems, say, globally on the Earth, and makes everybody work from home for a year or two. Not that COVID has done that, but you now know what it's like to not be able to go out. And on the environmental side, one of the things I learned with our lunar agriculture program is, if you think about this for a minute, one of the most expensive costs for NASA is lifting things into space, and water is really expensive. Every astronaut reuses the water over and over. So when they're running and doing their exercise and sweating and breathing out and urinating, all of that water gets used again. If you have some experience in chemistry and you can figure out ways to reuse water more efficiently, NASA is very interested in that, because you can save a lot of money for long spaceflight missions and for being on Mars. You can't get to Mars very quickly. If you have a problem with your water, you're out of luck. So you need to figure out how to hang on to it. So there are a lot of non-engineering jobs at NASA.
Alrighty, one more question from the audience. What year in your college education do you believe is the best to apply for internships?
I think it might be the junior year. Quite frankly, that would give the senior year to consider what's been done. But if it isn't a senior year, it probably would be a small difference. But if you have the junior year, you can come back and then work with your university and then go back with a second term. And I think that's probably the best plan. But actually, even if you did it in your senior year, it would be good, especially those that lead to presence at the centers.
So I applied every semester since I got into college. I always knew I really wanted to work at NASA. So it really, in my experience, doesn't matter. A lot of the stuff that you learn, you can learn on the job. I would definitely say at least your sophomore year, though, if you have a choice. But there's multiple different internship types too. So there's a standard internship where it's just one semester, one and done, and you apply to the specific position. Then there's also a pathways internship where you do 3 different tours. You intern 3 different times across the center, and you have to do one in the flight ops, which is the ISS. It's like where I work, aircraft operations, things like that. And then there's then one in the engineering, and then the third one you can pick wherever. And so that one you get multiple opportunities. So the pathways is a little bit harder to get into, but that one you're I don't want to say guaranteed, but you go through a selection process at the very end, and if they liked you enough, then you might have an opportunity to get hired. So, and those, like I said, you have to do 3 internships. So it's best to get in early, because if you're in your senior year, you can't really finish at the time. So just thoughts like that.
Alrighty. Where do you think NASA is headed in the future, or what do you think is next for NASA?
I was part of 3 return to the moon planning missions since 1989, And of course, none of them happened. But I feel encouraged that the Artemis program is going forward. And there's maybe political reasons, but first of all, it used to be, I would tell my class that I would teach about this, that whenever administration changed, NASA's plans changed. But that hasn't happened this time. So I think we have a real chance to return to the moon. But again, I've been part of 3 mission plannings to go back to the moon. But I believe this one will happen. I'm not sure about 2024, but I am pretty sure it will happen.
As best I can tell, NASA is aiming for a more continuous presence, maybe not on the moon, but they're building the Gateway project so that they can continue on past there. You know, once again, it's expensive to lift off the planet, off of Earth. And if we can build things, if we can manufacture things in space, the costs become much less. So, you know, I really do think that we're heading towards more permanent presence. There is the plan to try to get to Mars. There are a lot of questions still. It's a long journey, and we haven't actually had anybody on that long a journey in space. So we don't even know what all of the physiological effects will be to people. But that's why we need to get back up there, because you can't replicate all of that here on the planet.
Yeah, that's correct. Both comments I agree with wholeheartedly. I know that we, from the meetings I've been in at Johnson, we are currently planning to proceed with the Gateway program. As I mentioned earlier in my introduction, from the Gateway program, go back to the moon. 2024 is an aggressive schedule, as we all know. But I think that all in all, that we will definitely be back there once we build some confidence with Gateway, as we have built confidence with Station, and we did with the past shuttle program.
Alrighty, that concludes the webinar. If you have any questions regarding my organization, the Sigma Phi Delta Engineering Fraternity, or interested in joining the organization, I'm going to put my contact information in the chat. And if you have any questions for the Lamar University Engineering Department, they will be putting their contact information as well. I hope you all learned something and enjoyed the webinar. I hope you all have a nice weekend.
All right, thank you, Dylan, for pulling all that together. It was very informative for me as well.
All right, no problem. Thank you all for your time and for just being here. I really appreciate it.
All right. Oh, too much water. Leave this up here, so let's go.